Hi everyone, today we're talking about how to solve quadratic equations by factorization. You might remember from before that an equation could be expressed in this format: ax squared plus bx plus c equals 0. And when that is true, a, b, and c are actually constants, they're numbers where they don't equal to 0, or else it would make that whole term disappear, right? And it is called a quadratic equation. Today we're going to talk about how the solutions to these equations are actually called roots. So this vocabulary word should be put into your notebook. A root, or the solution of the equation, is a value of x that satisfies the equation. So it's a value for x where the equation will actually be equal to 0. Quadratic equations can be solved by factorization. So we're going to review that method. And then later on in this chapter, we're actually going to learn about some other methods. So we're just reviewing factorization today. Okay? And if you remember from factorization, you ended up with two binomials that multiply by each other. I'm going to give you an example, like x plus 3 times x minus 4 equals 0, right? And knowing that these two are related through multiplication, multiplication rules tell us that if one of these terms is 0, then it makes the entire equation equal to 0, right? So if it were 0 times x minus 4, then it would satisfy the answer of 0. Or if it was x plus 3 times 0, then that would also make it equal to 0. Okay, so that's why when you were solving these problems, the possible answers were -3 and 4. Because -3 plus 3 would become 0, then 0 times x minus 4 doesn't really matter what the other value is, it would equal to 0. Same with 4. 4 minus 4 would make this entire term equal to 0, then multiply by that other binomial, and it would just automatically become 0. Okay? So let's go through an example to review. Go ahead and pause the video and try this one on your own first before we start. Okay, so if you remember from our previous lessons, the first thing we would want to do is see if we can take out a GCF. But looks like we can't because there's no GCF that will go into 5, 58, and 24. So then we would have to use either the diamond box method or the AC method. So let's start first with the diamond box method. So we would have to figure out the AC value, which is 5 times -24. 5 times 24, but negative is -120. So we are looking for a value that can multiply, or two numbers that can multiply to get to 120, but then can add to get to -58. Okay? So we're going to first list all of our factors for 120. And honestly, I'm going to maybe start from the middle a little. So 120 divided by, let's say, 4 would get me 4 and 30. 120 divided by 5 would get me 5 and 24. 120 divided by 2. Ooh, 120 divided by 2. I shouldn't have gone that far. 2 and 60. Okay, so 2 and 60 can be added together. 2 and -60 can be added together to get to -58. And then they can multiply to get to -120. But one of them has to be negative, right? Okay. So let's go ahead and use 2 and -60. If you remember from the diamond box method, you basically have to now create your Punnett square. So we have our original 5x squared that's used, and our c value minus 24. And then these two get added in to our diagonal boxes, 2x and negative 60x. Okay, and then we have to work backwards to figure out what numbers, what terms go on the outside. 2x and negative 24 both have a 2. And then 5x squared and negative 60x both have an x and a 5. They both go into, or 5x goes into 5x squared and negative 60x. 2x and 5x squared both have an x, and I think that's it. These both have a negative, and let's see, I think 12 goes into both of them. Yeah, because 12 times 5 is 60, and 12 times 4 is 24. So that's the greatest common factor. And that's it. So let me go ahead and just check this really quick. 5x plus 2, and then x minus 12. Does that work? Let's see, 5x squared plus 2x, and then this is minus 60x minus 24 is 5x squared minus 58x minus 24. Yeah, it does work. Okay, and remember we have to set that equal to 0 because we're not done yet. We have to figure out the answer for x. Now, to figure out the answer for x, I need to set each of them equal to 0. So 5x plus 2 equals to 0, and then x minus 12 equals to 0. Because as long as one of these binomials ends up being equal to 0, it'll make the entire equation equal to 0, because anything times 0 is 0. Okay, so this is minus 2 to get x by itself, and then divide by 5. Okay, so one of my answers is negative 2/5. And the other is 12. X can equal 12 or negative 2/5 to get that answer of 0. Okay, now I'm actually going to show you the other method, which is our AC method. Okay, using the AC method, we would still figure out our AC, which is 5 times negative 24 or negative 120. And we would still have to figure out our two numbers that would add to get to negative 58, but multiply to get to negative 120. And we already did that, so I'm not going to do that again. We ended up with 2 and negative 60, right? Now with the AC method, you're going to replace this middle term with your two values. Okay, and then you're going to need to group your terms together. Okay, so I'm actually going to erase that because it's not actually multiplication. We're going to group it together like this. All right, what do 5x squared and 2x have in common? Well, they have an x, and that's it. So left over is 5x plus 2. And over here, what do negative 60x and negative 24 have in common? They both have a negative, and like we said before, a 12 in common. So then left over is 5x. Negative 12 times 5x gets you back to negative 60x. Negative 12 has to multiply by a positive 2 to get me back to that negative 24. So it's just like diamond box method was the opposite of Punnett square, the AC method is the opposite of double distribution. Okay, they both have this 5x plus 2 in common, so that's going to tell you that that's one of the binomials, and then the other one would be x minus 12, which is exactly what we got in our Punnett square method when we work backwards there. So again, both methods work to get you your final answer of x equals positive 12 and negative 2/5 when you set each of those binomials equal to 0. So use the method that you are more comfortable with. All right, let's move on to example 2 from the book. Solve the equation 4x plus 1 times x minus 3 equals 9x minus 28. Go ahead and pause the video and try it on your own first. All right, so I'm going to need to unravel this binomial here. So it becomes 4x squared plus x minus 12x minus 3 equals 9x minus 28. Okay, and then I'm going to need to put stuff together. This is minus 11x. Okay, and then I'm going to need to move everything to one side. I'm going to choose to move it over to the left side because I already have a positive x squared here. So that I have everything together, combine my like terms, have a 0 here, and I end up with 4x squared minus 20x plus, this is 25 equals 0. Do I have a GCF to take out? No, I don't again. So I'm going to go ahead and use either method that I like, whether it's the diamond box method or the repeated distribution, the opposite of the repeated distribution one, the AC method, okay? And then I'm going to set each of those binomials equal to 0. Okay, my AC is equal to 4 times 25, which is 100. So I need two numbers that multiply to get to 100, but add to get to 20. Let's see, I have 2 and 50, 4 and 25, 5 and 20, 10 and 10. Oh, of course, it's the last one that I think of, right? 10 and 10. So it's going to be negative 10 plus negative 10. That'll get me to the negative 20, but then multiply to get me to a positive 100. Okay. Let me use my my box method. So I have 4x squared and 25, but instead of this one, I'm going to use negative 10x and negative 10x. So what do these have in common? They have in common a 5, right? Because 5 times 2 is 10, 5 times 5. These two have a 2 and an x. These two up and down have a 2 in common and an x. And these two have, let's see, a 5. Let's pull out a negative. Yeah, let's pull out a negative because I know I need a negative in there somewhere. So I end up with 2x minus 5 times 2x minus 5. Oh my gosh. Just realized this is the special products and I wasted a lot of my time because I didn't think of my special products first. Yeah, I should have thought of that. So many lessons I'm learning. Yeah, square root of 4 is 2. Square root of 25 is 5. I could have just seen that and seen that it was a special product. Okay, 2x minus 5, set that equal to 0. Just need to do that once because the other one is the same. Man, you're learning so much from my mistakes. All right, so then x equals 5 halves. Okay. Okay, example 3 now. Solve this equation. Go ahead and pause the video and try it on your own first. Okay, so we have this equation. You know, I see that it has 3x plus 5 in both of them, and I am not into making any more mistakes today. Okay, so I'm just going to move them both over to one side. I'm not going to distribute. I don't want to create extra work for myself. I'm not into that after that last problem. Okay, so that cancels on this side, equals 0. So then I get 4x times 3x plus 5 minus 7 times 3x plus 5. Minus 5. Oh, I wrote the wrong thing there. Okay, because they both have 3x plus 5. So this really is kind of like the last step, one of the last steps in my AC method, my opposite of the double distribution. I see that they both have 3x plus 5, so I can go ahead and put them into their binomials, like that. So then I am almost done. I just have to set them each equal to 0. 4x minus 7 equals 0, and then 3x plus 5 equals 0. Plus 7 both sides, 4x equals 7, divide by 4, divide by 4. One of my answers is 7/4. And then the other answer, divide by 3, is negative 5/3. Boom. Ooh, I feel like I just saved myself a lot of work there because it was already set up where they both were being multiplied by 3x plus 5. So then I could just take out 4x minus 7 and put that in its own binomial.